Hello and welcome back, everybody. My name's Adam, and today we are going to learn about rainbow button configuration, the builder pattern, and how it's used to build custom button configurations. All right, let's jump right into it. So what is rainbow button configuration? Rainbow button configuration is just a structure, and that structure contains lots of properties that maintain the state about the appearance and customization options of your buttons. Now, to give you an example, this structure only has 3 of the many properties that Rainbow Button can be configured with. If you were to look at a fully realized Rainbow Button configuration, it might have up to 14 different types of properties. And this is just for now, because these are the appearance and customization options that are available through the SwiftUI component library at this moment, but that will definitely increase over time. Enter the builder pattern. So what is the builder pattern? Well, simply put, it's a creational design pattern that helps you create complex objects. It makes it so the person who is using that object requires less knowledge about how that object is configured. Now, why would we use it? It does help our code be more flexible because it allows for a step-by-step construction of these objects, and it makes our code more readable by clearly showing the construction process. And we're going to see this all in a demo in Swift Playground. All right, so we've created a Swift Playground called Builder, and we're going to use this to walk through some more concrete examples of the what and why of the creational design pattern called the builder. So let's just talk a little bit about abstraction. When we talk about abstraction, what we're talking about is the idea of a blueprint of some sort of representation of information. Now, in this case, we'll just say a class car. And this is going to be our abstraction, aka our blueprint to create cars. So let's give this a couple properties, like the make, which is a string, like the model, which is a string, like the year, which could be a string, and we'll give it a color. And we'll just say that's a color that we can pass. Now, obviously, we could design this in 100 different ways, but this is just for us to be able to learn about what the builder pattern is and why we want to use it and how it's used in the Rainbow library in order for us to put together this full 360 understanding of Rainbow button configuration and its builder class. Okay, so we have the abstraction, we have a class called car, it's got a couple properties on it. Now, if we wanted to create a car, so we're going to say we want to initialize an object or aka create a car, then we can say let car is equal to car. Now, this is, if you notice, the keyword create means that this is the creational part of the object's construction. Now, if we were to assign it values, then we would say things like car make is equal to Honda, car model might equal to CRV, and the year might equal 2024, and the car's color might be blue. Now, the problem is with this abstraction and its design is that we, at the point of initialization, at the point of the creation of the car, we actually haven't given it any values. So at this point, if we were to print the car has no information and it's got no properties assigned to it. And then if we were to print the car at this point in time, only now do we have things like make, model, year, and color. Okay. So with this design, with optional values and no initializer, that means that we have to assign values after the fact and after the point of initialization and the object's creation. Now, the whole point of the builder pattern is to start to lend itself well towards being able to construct this object in a readable, flexible, and immutable way. And we're going to build up to that in a second. So now that we know that this approach is not at the point of creation, what we want to do is we want to make some changes to our abstraction to change the way that the client has to deal with this object and deal with the construction of this object. Now you can see that class car has no initializers, and you can also see that we can't construct the car because it has no accessible initializers. So the first thing that you're going to think is, okay, let's create an initializer. Now that we created an initializer, you can see that the initialization function has a set parameter list that moves from left to right. And that parameter list starts with make, model, year, and ends with color. If I were to try and create the car, I would have to pass in these values at the point of creation now. So here, we're going to say that the make is a Honda, the model is a CRV, and the year is 2024, and the color is blue. Now let's think about this for a second. As a person who is trying to utilize this object of car, I now have to know that the make comes first before the model comes before the year, and the year comes before the color. What I mean by that is if we were to switch the order of these parameters, we're going to get a compilation issue and we wouldn't be able to construct the object. So as you can see, when we click the warning, it says argument make must precede argument model. The order of these parameters is incorrect. So there's a lot of boilerplate knowledge that I need to know in order to use this object. Okay, now imagine if we were to deal with all of the amount of properties, the 14 properties that you just saw on the rainbow button configuration. It's a lot of upfront knowledge for you to have in order to be able to build buttons. Okay, so what am I getting at? How do we solve this problem where we want to be able to make it that the person who is utilizing the button can pass properties in any order, and they don't need to know all the properties to pass in the first place? All right. Introducing the idea of the button builder. So let's just comment this code out for now. And we'll go ahead and just grab a code snippet on the car builder just to save some time. All right. Now let's inspect this class now called car builder, and we're going to refactor this code together to be a little bit nicer. So we have this idea of a builder, and it's got a private car. So this is a private reference to an abstraction that is going to hold values that is going to be set through the builder. And as you can see, the class car builder offers a signature called setMake, setModel, setYear, setColor, and internally in these functions, we are assigning the external value that's coming into the builder, aka the parameters to these functions. They are being assigned to the properties of the abstraction. Now, once we set these values, then ultimately we want to build the car. And that's why you can see the builder method's build function returns a fully realized abstraction. Okay, a lot of talk, but how does this actually work? So let's go ahead and change some values because we did get some of the interface wrong. We'll change the year to an int. Okay, and now we're going to remove this initializer because we're going to initialize the abstraction through the builder instead of the abstraction's initialization function that had all those issues that we were talking about. And we're going to make these properties optional because we don't need them at the point of creation. We can create the car and abstract the creation process through the builder, and we'll see what that looks like in a minute. All right, so we also had this as a string. We'll just change this to type color. Okay, so we're going to zoom out a little bit. Now we want to use the builder to construct a car. So now we're going to say let car is equal to car builder, and car builder might set the make, which is going to be a Honda, might set the year, which is going to be 2024, and it might set the color, which is going to be blue, and finally we will set the model, and this is going to be the CRV. Now, what have we done here? Well, we called a bunch of functions, so let's just walk through it. So we have the let car, which is basically the value that we are trying to assign the car to. And we have this idea of a builder. Now we call set make and we pass in a string called Honda. If we go to set make, you can see that the string called Honda is coming through here as a parameter. So this value is Honda and it's being assigned to car make property, and car is a private property on the builder. Okay, so now that we know that, all we need to do is call the build function in order to construct the car. So we'll just go ahead and call build. And then when we print the car, we'll just go ahead and run that in the playground. You can see that we get the car created with the Honda CRV, the year, and the color. Okay, now just circling back to for a minute, if we were to try and switch the order of these functions, you can see it really doesn't matter. We can put them in any order and we have no compilation issues and the car is built accordingly. So this time when we constructed a car, we actually set the values in a flexible, composable way that requires less knowledge to the person trying to utilize the object, because they don't need to call any of these functions. It's up to them to call whatever they want because all of the properties under the hood are optional. So now, ultimately, the person can build a car as complex as they like or keep it as simple as they like. And you can see that the car gets constructed as it usually would. Okay, so now that we have this fundamental understanding of the builder pattern, let's just refactor this code a little bit to show you how it actually gets implemented in Rainbow Button configuration. And in Rainbow Button configuration, we do have it implemented as a class. However, I'm just going to go ahead and remove car from these return values. And again, use your imagination here a little bit. We're going to get into the actual Rainbow code in a second. So we have a class called builder, but we implement it as an extension on car, which in this case is going to be the Rainbow Button configuration, and it implements a builder. So instead of having a separate object, we can just say car.builder. And we have a little bit of a cleaner interface that way. All right, so let's go ahead and jump into Xcode and see how this maps to Rainbow Button configuration, its pre-configurations, and its builder. Okay, so we're back in the content view from our original sample app that we've been building for the past few episodes. And inside the project navigator, we have opened up the Rainbow dependencies so we can actually browse the source code in the dependency itself. So the source code that we're interested in for today is the Rainbow Button configuration and the Rainbow Button configuration builder. Now, as we mentioned before, if we look at the initialization function of the Rainbow Button configuration, you can see there's tons of properties. And knowing this information up front, being able to understand what orders to put these properties in, it's not going to be a fun time if you're trying to build custom configurations. So for that purpose, we implement the rainbow button configuration builder, which, as I showed you earlier, is a public class that extends rainbow button configuration. And ultimately, it has all of those different setter methods that we discussed a moment ago. However, the build method just constructs the rainbow button configuration the same way that we just built a car in the previous uh, demonstration. So, okay, so now that we understand that, what we can look at is the rainbow buttons pre-configurations, which are built using the rainbow button configuration builder. So if you were to scroll past the struct for rainbow button configuration, so this is the struct for rainbow button configuration inside the rainbow library. So we're just going to go ahead and collapse that code. If we go ahead and scroll down to the various predefined button configurations, you can see that all of the predefined configurations are simply just different variations of the rainbow button configuration builder. And so ultimately, we have some that are simple and we have some that are complex. And you can test all these out in your code by simply copying and paste this or using the pre-configuration yourself. And what I mean by that is if you go in the content view.swift and you just pass the rainbow button modifier a pre-configuration like success inverted, then you're actually playing with the rainbow button configurations behind the scenes. And those rainbow button configurations were built using the rainbow button configuration builder. Okay, so now that that's understood, I do want to just take a last moment in this walkthrough to illustrate the sample app for Rainbow. And this is the Rainbow examples repository, which you can find as a sibling to the Rainbow repository in iHeart Swift's organization on GitHub. And I will drop a link to that in the comments below. But I do definitely recommend downloading the Rainbow Buttons example project. And inside the Rainbow Buttons example project, we have an example called Example Buttons View. And if you click this, you will see some of these really complex buttons that you see below is actually just really different complex configurations using the Rainbow Button Builder. So just to give you an example, this one here with the custom border where I hold it, the selected state is yellow, I let go, there's rainbow loaders. This is actually in the custom example or in the example buttons view. This is just a custom example that I put together from a button that I saw in an app called Rainbow Wallet. And I really like that button, so I rebuilt it using the Rainbow Button Configuration Builder. And you can see all the different properties that I assigned to the configuration through the builder in the examples app. All right, so that's it for today. I will see you in the next episode where we will learn a little bit about Rainbow Progress, which is a different component. But if you have any questions or you're curious about the builder pattern or have an opinion or even want to contribute, feel free to drop a comment and I'll see you in the next one. Ciao.